Okay, Assalamu alaikum. This weekend I won't be able to schedule any live sessions, and as you told, you have examination in this chapter on Monday. I'm just recording this video and I will upload it on my YouTube channel and send the link to you. Actually, you have just received the link of the video, so you can just watch the video. And if you don't understand anything after that, or if you have any doubts, you can just drop me a WhatsApp message. I will clarify them, right? So what we are going to study in this chapter is preparation of salts, right? So salts we have already studied. They are the yields of acid-base reaction, right? So we can classify these salts into two categories, right? So that's what we have to study beforehand, because we are going to prepare soluble salts in the laboratory settings, right? So what are soluble salts, right? So this is the one category of our salts, right? So what we are going to do here is we will just classify the term salts into two categories. So let me write it over here. So salt, right? So we have two types of salts, right? So the first one is soluble salt, right? Soluble salt, and the other one is insoluble salt, right? Insoluble salt, right? So what are soluble salts? So soluble salts can easily dissolve in water and form a solution, right? So soluble salts, right? So let me write over here. They can dissolve, they can easily dissolve in water and form solutions, right? So they will not exist as solid in the solution. So if you have a solid, for example, if you take salt from the kitchen and dissolve in the water, you cannot observe any solid particles. The entire salt will dissolve until it reaches saturated state, right? So solution. Okay, right. And what are insoluble salts? So they cannot dissolve in water significantly, right? So sometimes we might categorize into sparingly soluble salts also. Sparingly means only a few amount of salt will dissolve, and you can observe both solution and solid particles, right? Okay, anyhow, we will just classify it into only two categories for now: soluble and insoluble, right? So they do not significantly dissolve, right? Now we have to look at some examples for soluble and insoluble salts, right? So I will tell you all the examples, right? So salts that can be soluble are, we have all, okay, for example, if you have sodium, potassium, ammonium salts, right? So if I tabulate the examples of soluble and insoluble salts, right? So it will be like this: all sodium, potassium, and ammonium, okay, ammonium and nitrate also, all nitrates are also soluble, right? Okay, I'm just writing over here, right? So all sodium, if I write over here like that, okay, all sodium, potassium, ammonium and nitrates, potassium, nitrates, okay, ammonium salts, right? All sodium salts, if I write this way, you can easily understand. All potassium salts and all ammonium salts, all ammonium salts, right? And all nitrates, they are soluble. For example, if you take sodium salts, for example NaCl, right, and NaNO3, right? So now these are the salts of sodium, right? And if you take even sodium sulfate, whatever the sodium salts, right? So the cation will be sodium, and you can combine the cation with any anion, right? Okay, and even sodium bromide, anything, All are soluble. If you put sodium chloride into water, it will dissolve. It will not deposit on the bottom as precipitate. It will completely dissolve. Again, potassium chloride and so on. And ammonium, for example, ammonium sulfate, ammonium nitrate, all are soluble, and nitrates, right? So nitrates, right? So these are all soluble. Now again what we will see is chlorides, right? So now all chlorides are soluble except PbCl2 and AgCl, right? So only Pb. Okay, now the next category, all chlorides except PbCl2 and AgCl. Only these two chlorides are insoluble in water, and the rest of the chlorides will be soluble. Right. The next one will be all sulfates. Now if you take all sulfates are soluble in water except PbSO4, barium sulfate and calcium sulfate, right? So now we will study all sulfates except Pb, lead sulfate, calcium sulfate and barium sulfate, right? So you should remember this chart. Now even though it will not help right now, when you go to the higher grades it will definitely helpful for you. So you better remember this table, right? Okay. Now again we will have to look at another category of soluble and insoluble salts. They are carbonates, right? So all carbonates are insoluble. For example, if you take calcium carbonate, and it will not dissolve in water, right? Except sodium carbonate, potassium carbonate and ammonium carbonate, right? So why? Because sodium we have already studied, right? Any salt of sodium, potassium and ammonium will dissolve in water. So except sodium carbonate, Na2CO3, potassium carbonate, K2CO3 and ammonium carbonate, NH4 twice CO3, right? So only these carbonate will dissolve in water, and the rest of the carbonates will be insoluble. They will not dissolve, right? So let me repeat it again. Now we classified salts into two major categories. The first one is soluble and the other one is insoluble, right? So what are soluble salts? They can easily dissolve in water and form solutions. In other hand, the insoluble salts do not significantly dissolve, right? Okay, now we looked at some examples or the examples or substances for soluble and insoluble salts. First one is all sodium chloride. Now you see all sodium, potassium and ammonium, right? Right. So all sodium, potassium and ammonium and nitrate salts are soluble, right? So for example, what can you tell? Sodium chloride, sodium nitrate, sodium nitrate, whatever, right? Potassium nitrate, okay, sodium sulfate. These are all soluble. Now the other example is all chloride. For example, sodium chloride, potassium chloride, we already studied, right? Okay, now with respect to cations, we discussed the example. Now from here we are going to discuss the example with respect to anions, right? So all chlorides except PbCl2 and AgCl. Only PbCl2 and AgCl will be insoluble in water, and the rest of the chloride, for example potassium, magnesium chloride, everything will be soluble in water, right? The other category is all sulfate, right? For example, sodium sulfate, potassium sulfate, magnesium sulfate, barium, except barium sulfate, because barium sulfate is not, right? So barium sulfate is insoluble, right? So you should remember this, right? So you can just write this down and paste on the wall, and every time you have to look at so that you can remember this chart, so that it will be helpful for you in future, inshallah. Okay, right? So only Pb sulfate, lead sulfate, calcium sulfate and barium sulfate will be insoluble, and the rest of the sulfates will be soluble, and sodium carbonate, potassium carbonate and ammonium carbonate. Alright, so only these carbonates will be soluble and the rest of the carbonates will be insoluble, right? Okay, now the other thing is we have two methods for preparing salts in the laboratory setting. They are right. So we will just see two methods for preparing salts in the laboratory. Two methods, okay, of preparing salts in lab, right? Okay, the first method is called method A. In method A, we will make metals, bases or carbonates in acid, right? So but we will use these metals or base or carbonates in excess in order to make sure that all the acids are utilized during the reaction, right? Which means all acids are consumed at the end of the reaction. So method 1 will be by using excess amount of metal ion, base or carbonate in acid followed by titration. Okay, so followed by filtration, okay, because titration is the next method, the method B, by followed by filtration, right? So what we are going to do is, now we will just take some acid into a beaker and we will put some excess amount of metal. What will happen? For example, we have studied some characteristic equation or characteristic reactions for acids, right? So acids can mainly involve in three characteristic equation. They are, right? So we will first look at that one and come here, right? So now we will just study characteristic reactions for acids, right? The first one is not new to you. We have already studied acid plus base, right? So acid can react with bases to produce salt, right? So as you can see here, in the product we get salt. So this way can be utilized to produce salts in the laboratory. And in addition to that, we will have water also, right? So this is the first method we are going to use in order to produce salts from the laboratory, right? Okay. The second one, for example, if I take an example, HCl plus NaOH will give you NaCl and water, H2O, right? And the other one will be metal plus acid will give you what do you call it will also give you salt, right? Okay, now depending on the type of acid, you will get gas, right? So if you use HCl, you will get hydrogen gas. If you use H2SO4, you will get hydrogen or SO2 gas. And if you use nitric acid, you will get NO2 gas, right? Okay. Now, for now, we will not talk about H2SO4 and HNO3. We will just talk about HCl for now, right? So we will just take the acid HCl, and later we will study about H2SO4 and HNO3, right? Where we will get different gases also, right? So acid plus gas, right? So this gas might be H2, SO2 or NO gas or even NO2 gas. Depending on the type of acid you are using, you will get one of these gas, right, in addition to salt. So what we are interested in here is producing salts. So if you make metal react with acid, you will get salt, and the gas will go to the environment, I mean the atmosphere. So we don't need to worry about these gases. We can produce salts, right? So we can use this acid, right? So we have studied HCl, H2SO4 and HNO3, right? Okay, depending on the condition of the acid also we will get different gases, right? So we will talk about those stuffs in inorganic chemistry when you study those things, right? Now I will just consider only HCl here, right? I will just only consider HCl. So when metal reacts with acid, I mean HCl, it will produce H2 gas, right? So we don't need to worry about these gases for now, right? Okay. Now if I take a simple example, now let's say we take sodium, right? So sodium plus let's say we take sodium and okay, if I take magnesium then it will be, yeah, okay. So let's say we take magnesium and we make it react with HCl, right? So what will it produce? Now magnesium will lose 2 electrons and produce Mg2 plus cation. Now this H plus will dissociate as H plus and Cl minus, right? So in the reactions chamber we have 2 cations and 1 anion, 2 cations and 1 anion, right? So now we have to now the reactivity series should come into play, right? Okay, so we have reactivity series. Now you are familiar with it, right? So potassium okay, so you can use mnemonic, or if you remember this one you can just write, and in this direction from left to right what will happen to the reactivity of these metals will reduce. Now you see here in the reaction chamber we have magnesium 2 plus and H plus, right? So we have magnesium 2 plus, which means magnesium, we have magnesium and H plus. So magnesium is more reactive than H plus ion. So what will happen, this magnesium 2 plus will replace this H plus and join with Cl minus. This is something like this, right? So this magnesium 2 plus is a stronger guy, but H plus is a weaker guy. So with anion the weaker guy is attached. So what will happen if a strong guy comes into the system, he will replace this, or he will kick away this H plus and join with Cl minus. So we will have magnesium chloride and H2 gas. Why? Because H plus is isolated, and from another okay, now we will have many magnesium atoms and many HCl molecules, right? So one magnesium atom will produce magnesium 2 plus ion, and another magnesium atom will produce magnesium ion and magnesium ion, right? So again we will have, now if you have two for example, let's say, okay, now if you balance this equation it will be something like this, right? Okay, so now we need 1 mole of magnesium and 2 mole of HCl to produce 1 mole of MgCl2 and 1 mole of H2. So this is what will happen here, right? Okay, now I will just explain you how this reaction will happen here. Oh, why isn't it working? Okay, just let me zoom out it and bring here, right, so that I can create some space. Okay, so now the reaction that we are going to discuss here is this, right? So now let's say we have 1 magnesium atom, right? So this is how the reaction will happen. So we can call it as mechanism of this reaction. Okay, so we have 1 magnesium atom, and this magnesium atom will produce 1 magnesium 2 plus by removing 2 electrons, right? Okay, and we have 2 HCl, right? So we require 2 HCl to happen, to make this reaction happen. So we have HCl, 1 HCl will produce H plus and Cl minus, and another HCl will produce H plus and Cl minus. Okay, Cl minus. Now what will happen, this chlorine and this chlorine sums up sum up to two negative ions, and here we have two positive ions. So these three ions will now make MgCl2, right? So MgCl2. Now it is a neutral substance. Okay. Now this H plus is isolated and this H plus is isolated. So they will come together and form H2 gas, right? H2 gas. This is how this reaction will happen. Okay, right. So okay, so far we have discussed the second characteristic reaction regarding acid. Now the third one will be, we have already studied this also in the previous chapter. Now I told you carbonates can react with acid, right? So carbonate. So carbonate plus acid will give you what? A salt. A salt plus carbon dioxide plus water. So if I take an example, now what you should know here is, now if you have a carbonate ion and if you put acidic medium, it will produce carbon dioxide. Always it will produce carbon dioxide. So you should remember this. So CO3 2 minus and H plus will give you CO2 gas. So I told you to remember this, right? So I told you to remember this. Now if I take an example, let's say I take sodium carbonate Na2CO3 and I put HCl, what will happen? Now here we have Na plus and CO3 2 minus, and this can dissociate as H plus and Cl minus. So what will happen? Now this carbonate and H plus will produce CO2 gas, and we have Na plus and Cl minus, Na plus and Cl minus. So NaCl will be produced as salt, and during an acid base reaction, this is an unwritten rule, water will anyways produce, right? So when you balance the equation to equate the number of oxygen, we will have to put H2O, right? So when we balance the equation, automatically water will come. So this is how we write on the paper, but in the laboratory settings, what will happen, right? So we will discuss that. Okay, so before that we will just try to balance the equation, right? So now we have two sodium carbonate, right? So we have in sodium carbonate we have two sodium atoms, right? I don't know if you can see my pen pointer in the video, right? Okay, so what we will do is, we have two sodium atoms in sodium carbonate, so we will multiply sodium chloride by 2, right? So we have two chlorines here, so we are supposed to multiply HCl by 2. Now we have 3 oxygen, and here we have 2 oxygen, and if you put 1 water, so it will be automatically balanced. Now we will see how this reaction will happen. Okay, right. So let me so here what will happen, we should have Na2CO3, right? Na2CO3. Now I told you all the carbonates are insoluble except sodium carbonate and potassium carbonate and ammonium carbonate, right? Okay, so now what we will do is, if you, now in the system we have water, right? Because all reactions are happening in aqueous medium, right? So what will happen, this will dissociate as Na plus and CO3 2 minus, right? And we will have 2 Na plus and 1 CO3 2 minus. Now we have 2 HCl molecules, right? So one HCl will dissociate as H plus and Cl minus, another HCl will dissociate as H plus and Cl minus. Now here you can see here, now we have two positive ions and two negative ions, right? So these will form NaCl, right? So these three will form now NaCl, and here you can see in acidic medium this CO3 2 minus will be will become CO2 gas because of this acidic medium. And again what will happen, these isolated H plus ions will react to the lost oxygen from carbonate and form H2O, right? So now you see here, now okay, now I told you with the presence of acidic medium, what will happen, carbonate will become CO2. Now you see here, in carbonate we had 3 oxygen atoms, but here we have only 1 oxygen atoms. So what will happen, now the number of oxygen has reduced to 1 by 1, right? So 1 oxygen is lost. So this oxygen O2 minus will now react with these H plus and H plus and form H2O, right? H2O. Have you understood this now? Right. Okay, so this is how this reaction happens in the reaction system. Okay, now we have studied these 3 characteristic reaction for acid, and we will come to our 2 methods of preparing salts in the laboratory. So the first method would be by using excess amount of metal ion, base or carbonate in acid followed by filtration, right? So first we have to take excess amount of metal and make it react with acid, and then we will get some yields, but the yields will be in liquid form. So we have to filter it. Now we have already studied the separation methods, right? So the filtration method, now what we will do, okay, now if I have something like this, now if I take a conical flask, okay, and if I insert a funnel here into it, and I have to fold a filter paper and place here, and I have to pour the solution in the beaker after the reaction has occurred, right? So pour the solution, right? So what will happen, now we will have residue here, the solid particles residue, and we will get only the liquid portion also, that is called filtrate, right? Then again this filtrate should be evaporated to remove the water, and then the final product will be called crystals, right? So it will be in solid form, right? So then after filtration we have to do evaporation, right? So we have to evaporate the solid using we will use a apparatus called heat bath, right? So heat bath means we will not directly evaporate the solution because it should be evenly heated. So we will call something called water bath, right? So water bath, right? So we will see the procedure later on. Then again we will get the crystallization, right? So we will use crystallization to obtain the crystals. Now we will look at the procedure later on, but now I have to just introduce the 2 methods. The method 1 is using excess amount of metal by base carbonate in acid, right? Okay, now a question may arise, why we need to use this excess amount, right? So why should we use this excess amount is, now we have to make sure that the acid is completely consumed, right? So if you use excess amount of metal, what will happen, all the acids will be utilized at the end of the reaction. But if you add a small portion of acid, I mean the metal, what will happen, you don't know whether all the acids reacted, right? Then the final solution that you pour into this funnel will contain some acid, and it will affect our efficiency of our it will reduce the efficiency of our experiment. So we have to use excess amount of metal or base or carbonate, whatever we are using, okay, right? So why, to make sure that all acid are consumed, right? So this is the purpose of using excess amount of metal, right? Okay. And the next second method, we have already studied that one, right? So in the previous class, method 2 will be titration, right? The titration. Okay, so I am not going to talk about titration here. We will just look at the diagram that is given in the first page of your book, and then the method, right? Okay, right, now we will come to this page, right? So now we have this diagram. So this is how we are going to proceed with what method we are going to use in order to prepare the salt. Okay, right. So beforehand we have something here, right? So now we will just try to read it and understand, right? So now now you see here choosing a method of salt preparation, right? So now we have studied two methods, right? The first one is using excess amount of whatever, right? It may be either solid metal or base or even carbonate, right? And the other one will be titration, right? So the choice of method for preparing a soluble salt depends on the two things, right? Now we have to ask two questions, right? So let me just explain this diagram to you. Now we will always take metal, right? Why we are taking metal is, now the reactivity of metal is higher. Okay, now if the reactivity of metal with acid is higher than that of carbonates and bases. So when we want to produce salt, now we have to quickly form the salts, right? So we will take a reaction which has low rate of reaction, right? So now if I order the rate of reaction with acid, right? So I will use something, okay, right? Now we will discuss, right? So acid can react with metal, base and carbonate. So these three types of reactions we have studied, right? Now if I order the rate of reaction with acid, with acid, now if acid reacts with metal, base and carbonates respectively, and if I order the rate of reaction will be like this. Metals will have high rate than carbonates, and the rate of reaction with acid and bases will be less, right? Comparatively less, right? Okay. Now if I select this metal, I can quickly produce a salt, right? So we will prefer this method, right? Now not all metals will react with acid. Why? Because the H plus should be able to replace by the metal ion. So the metal ion should be more reactive than hydrogen. For example, if I take Zn and if you put HCl, according to the reactivity series, Zn is more reactive than H plus ions, right? So what will happen? This zinc ions will replace this H plus and form ZnCl2, and during this reaction H2 gas also will be formed. Now if I take copper, what will happen? If I put copper into HCl, what will happen? In the reactivity series we already discussed, where is that? Okay, just look at this one. Now in the reactivity series, copper is after H plus, which means the reactivity of copper is less than hydrogen. So copper cannot replace hydrogen ions from the acid. So this reaction will not be practically possible. This will not happen. Which reaction? This reaction will not happen, right? Why this reaction will not happen? Because copper cannot replace H plus in HCl, as its reactivity is less than H plus hydrogen, right? H plus hydrogen or whatever, right? So this is the scene happening here, right? So if you put copper metal into HCl, nothing will happen. Copper will just deposit on the sink to the bottom. That's all. Nothing will happen. But when you put Zn, what will happen? You can observe effervescence of gas because of this H2 gas formation, and you can get a chloride solution, zinc chloride solution. Okay, right. Now we will try to, okay, I can just erase all these things to create some spaces. Yeah. Okay, right. So now we will ask two questions, right? So what we have already discussed is now the reactivity of acid metal reaction will be high, so we will prefer that reaction, right? So now I will take a metal, right? So metal. Now some metals are more reactive. Now if you take potassium in and take it into water, it will vigorously react and form fire also. So it is not safe, right? So what factors that we will consider here is, now first if you take metal, first you have to ask whether this metal will react with it, because some metals do not react with acid, right? So what you have to do here is, now okay, now if you take a metal, right? So now if you take a metal, now any metal you can take, right? So let's say we have taken Zn, magnesium and copper, right? So we have taken just three metals, right? So this zinc will react with HCl, magnesium will react with HCl, but copper will not react, right? So now we have to first ask this question, why? We have to just ask this question whether the metal reacts with acid, right? So the first question that you have to ask is, does the metal you took react with acid? Now the answer might be either yes or no, right? So if the answer is yes, now we have to ask another two questions, right? What are they? Now if the metal is more reactive, practically we cannot do it in the laboratory because the entire laboratory might explode sometimes, right? So what we will ask is, now we will ask whether this is safe or not. Is it safe? Which means, is the reaction vigorous or moderate, right? If the reaction is moderate, now you see here, if you take zinc, magnesium, if you take magnesium, it will not be safe, right? So this is not safe because potassium, sodium, magnesium, the elements occurring in the beginning of the reactivity series will react with acid more vigorously, so we will avoid it, right? So it is not safe, we will not go for magnesium. But if it is zinc, okay, because zinc is somewhere here, so it's okay to perform this experiment in the laboratory. So we will ask whether it is safe or not, right? So if it is yes, we will proceed further, but if it is no, we will abstain from doing that experiment. We will not go for it, right? So now if you take metal, two main questions you should ask. The first one is, does the metal react with acid, and is it safe? Is it safe? Okay, now is it safe? Now if the answer is yes for the first question, only we will ask the second question. If this is no, then again we will go for the next method. We will take base or carbonates, right? Otherwise we will not, because you see, now the metal does not react. So even if you perform this reaction, you will not get salt, right? But our purpose is to produce salt, so this is not possible, so we will not go for it. And even if it is not safe, then again we cannot produce, right? In order to make a salt, we cannot put our lives into risk, right? So we will not go for it. If the answer for the first and second question is only, we will take the metal and make it react with acid. Okay, right? So we will take zinc and make it react with HCl. So we will get magnesium chloride. Okay, so we will just see this diagram. Here they have given, right? So now if you take the start, right, we will take a metal. Now if this is yes, and we will ask if it is method yes, right? So what will happen? We will go for method A, right? So method A means we will just take, okay, now we see, now we can use zinc in HCl, right? So if you take HCl and if you put excess amount of zinc, what will happen? Now Zn will react with HCl to produce ZnCl2 and H2 gas. So we have produced ZnCl2 salt, right? So you can see here ZnCl2 salt has been produced. And again, if you take magnesium and if you take H2SO4, what will happen? It will produce SO4, right? So you can produce MgSO4 also. Don't worry about this water, right? Because, okay, now don't worry about this water. MgSO4 will be produced. So yeah, this is okay, right? Right. So now, okay, so I told you magnesium, okay, so depending on the situation, right? Sometimes it might be slightly safe, so you can consider. But if you take potassium, right? So I'm telling, right? So if you take potassium or sodium, they will not be safe, right? They will not be definitely safe, but magnesium may be sometimes safe, right? So this is okay, this is safe. But potassium and sodium, even if you put sodium into water, it will vigorously react, and if you put HCl, what will happen? The reaction will be more vigorous, so it's not safe, right? So we will not for it, right? Okay, so we have produced these salts. Okay, right. Now if the answer is no for these two questions, right? So if the answer is no for these two questions, now we will take base or carbonate, right? And now what we have to ask is, now if metal does not work, if the metal does not work, now the other reactants that we have are bases and carbonates. Right. Now if you take a base, right? So for example, let's say we have taken NaOH, right? And let's say we have taken a carbonate. So if you take a carbonate, now let's say, right, okay, any carbonate we can take. Now if the carbonate is soluble, right, so normally the carbonates we have some, all carbonates are insoluble, right? So except sodium carbonate, potassium carbonate and ammonium carbonate, the rest of the carbonates are insoluble, right? Insoluble. So if they are insoluble only, we will go for method A. Why? Because if they are insoluble, because we are going to use excess amount of carbonate. Okay, now, okay, just understand this. Now if they are insoluble, we will go for method A. If they are soluble, we will go for method B, because we don't want to mix the excess amount of base or carbonate that we are taking into the salt solution, because we cannot separate them again, right? So practically we have some issues. So what we will do is, right, so what we will do here is, now you see, now I have just taken carbonate, right? So I'm not going to consider base. Now I will take carbonate, right? So carbonate, right? So carbonate, what you should know about carbonate is, we have all the carbonates insoluble except Na2CO3, potassium carbonate and ammonium carbonate, NH4 twice CO3, right? So only these three will be soluble in water, right? Except others will insoluble. Now if you take Na2CO3 and HCl we have taken, but we have to take carbonate in excess amount, right? Excess amount. So we will just take HCl in a beaker. This is HCl, and we pour excess amount of Na2CO3, right? So only a few amount. Oh, we don't know how much of sodium carbonate will be required for this reaction to happen, right? So what we will do is, we are adding excess amount. So in the system, at the end of the reaction, what we will have is, okay, now let's try to write down the reaction here. Na2CO3 plus HCl will form NaCl plus H2O plus CO2 gas. So we don't want to bother about carbon dioxide, because it will go to the atmosphere. So we have NaCl into it, and we have water H2O, and in addition to that, since we have added excess amount, the extra amount of sodium carbonate that was not reacted with HCl also will be in this container, right? So since this is insoluble, now in the now after that what will happen? Now here we will have extra amount of extra Na2CO3 as well. Now if you utilize these two filtration, right? So in the filtration, what will happen now with the sodium chloride solution, we will get Na2CO3 also, because it has dissolved. So when it goes to the filtrate, what will happen? We will get NaCl and Na2CO3. So when we evaporate and perform crystallization, in the final output we will have both NaCl and NO2CO3. So practically this is not possible. So if it is soluble, then we will go for titration. So this cannot be done using this method. This can be done only by titration. Why? In titration only we can get only the required amount of sodium carbonate, and we don't want to pour extra amount of sodium carbonate, right? But if you take for example calcium carbonate, okay, so what will happen? So let's say calcium carbonate. Now this calcium carbonate, it insoluble. Now if I put calcium carbonate into HCl, and if I put calcium carbonate, now what will happen? Now calcium carbonate plus HCl will give you calcium chloride plus CO2 plus water, right? So now ultimately we have only these. In addition to that, we have extra. Now this is reactant side before the reaction happens, or at the beginning of the reaction. After the reaction has finished, now we have extra amount of calcium carbonate. Why? We use excess amount, right? So more than what we require, we use more than what we require. So excess amount will be here, and the extra amount, the remaining amount after the reaction has finished, will be in the container even after the reaction. So what will happen? Now this extra calcium carbonate, now in water, now you see here we have no more, we have no more HCl. Only calcium carbonate can dissolve in HCl, but it cannot dissolve in water. We have already studied them, right? Okay, so calcium chloride will dissolve in water, because all chlorides are soluble except PbCl2 and AgCl. So calcium chloride will be in solution in liquid form, but calcium carbonate will not dissolve in water. So what we will have is, now if I put calcium carbonate solids into HCl aqueous, now we will have a solid, and the extra amount of calcium carbonate will sink to the bottom. It will not dissolve, but calcium chloride will be in solid will be in liquid form. So calcium chloride liquid, but extra calcium carbonate solid. Now when you filter, what will happen? The extra amount of calcium carbonate that we use during the reaction will be collected in the residue, in the filter paper. Only the calcium chloride will go to the filtrate, and we can get calcium chloride crystals by evaporation and crystallization method. Okay, so we have just studied everything regarding this diagram, this flow chart. Okay, right. Now we will see how this method A is carried out, right? So now, okay, now let's say we have taken dilute acid, for example HCl, and if you take zinc, right, for example, if they mentioned the one, yeah, okay, so this is how the method A will be carried out, right? So zinc chloride will be formed. Now we have to take hydrogen chloride, HCl acid, and we have to put some metals, and we have to stir it, right? And we have to heat it also in order to increase the rate of reaction, right? So what will happen? Effervescence of acid, effervescence of gas will be observed. So which means the gas is produced. Let me just go through it. Carbon dioxide. Yeah, now you see here the first picture. In first picture, if you use yeah, now this is what? Metal oxide. Here we use the pure metal, but here we use metal oxide, right? In okay, okay. Now, if you heat a metal oxide, also a salt can be produced, right? So you don't worry about it, right? Okay, right. Warm the acid, switch off the Bunsen burner, and then excess. Wait a minute. Yeah, so you can use this metal oxide in acid in order to produce salt, right? So that is also another method. For example, sodium oxide, they are insoluble, they are insoluble in water, so you can utilize this method, right? Okay. Now, as I mentioned you, this method, yeah, okay, now we will not focus on this, forget about this and second and third. Now this is the A method, right? So now this is for pure metal, this is for metal oxide, and here we are taking carbonate, right? So if you take metal carbonate, now this is something like this. Now if you take calcium carbonate, and if you yeah, okay, so if you take metal oxide, this is also possible because they are insoluble. And if you take metal oxide, for example calcium carbonate, and this is also insoluble, metal oxides are also insoluble, right? So I think I forgot to give that, right? So most of the metal oxides are insoluble, so you can use metal oxide and calcium carbonates, right? So only a few, right? So calcium carbonate, barium carbonate, and lead carbonate can be used for this method. Now you see here, at the end of the reaction we have to filter it, right? So now we have just used a filter paper, and we have just poured the mixture into it, and we can collect the filtrate, right? So this filtrate contains the solution of salt, right? Solution of salt, except because you even see now, even if you put zinc, the excess zinc will be collected in the what do you call this one, because metals do not dissolve. For example, zinc will not dissolve in water, right? So you can collect the extra amount of zinc or oxide or carbonate here. But if you are using bases, then bases cannot be used, because bases are all liquids and they are soluble in water, right? So so this method is not applicable for bases, so you cannot use that. So after that, what we will do is, now this filtrate will be taken, and we will evaporating basin, right? So you can use a water bath or evaporating basin, and then again after evaporation, what will happen, we will get the crystals, right? So crystals will be formed, right? Because in the salt solution, what we have salt solution contains salt and water, right? If you evaporate water, you will get the salt in crystals, right? Okay, so this is the procedure, and this is the water bath, right? So the usage or the advantage of using water bath is to evenly heat it, right? And even for safety precautions. Now sometimes the substances might directly react with fire, so for safety purposes and evenly heat it, we will use this water bath, right? So evaporating of the water to obtain the crystal, right? So we can follow this method, and this is how the final crystals will appear, right? So this is salt in the form of crystals, right? This is salt in the form of crystals. And again, we have already finished this titration part in the previous class. I don't think we don't want to study this now. And in the next session, we will discuss all these questions, inshallah. And I think I explained you these things also, right? Okay. And in the next session, we will try all these questions. And before that, you can ask your doubts, and during the session also we will clarify our doubts, right? So I just taught this titration method without teaching these stuffs, right? So that's why, and today I won't be able to conduct any sessions, live sessions, so I'm just recording this video and sending. Okay, so we will meet in the next session.